Oh, my head is cut off on there, but and let's get the share. If you want to join on YouTube, let me go back to Club Deck here for a moment. You can join that way as well. So, hello everyone. Welcome to Climate Chat. I'm your host, Dan Miller. Today, we're going to be talking probably about a number of things, but including a follow-up to some of the discussion that we've had on James Hansen's latest and kind of groundbreaking research showing that the IPCC has been underestimating both warming and cooling and the impacts and potential impacts that has caused, and by the way, as well as the controversy that has caused. And I think we'll also be talking about a recent article by Joe Romm, who says that direct air capture or taking CO2 out of the air using mechanical means is not feasible. And we'll, oh, hold on, I gotta let you all in here. Sorry, I forgot about the waiting room. Okay. And here we go. And Eli, I'm going to make you co-host so you can let others in. And here we go. My head is being cut off there in the top because of the background I have here, but if I can do it this way. So that's what we'll be talking about. Just to say it again, Jim Hansen's latest research that we've talked about a few times here already. There's a chance that Leon Simons, one of the co-authors of the paper, will join us, and if we do, then we'll certainly dig into it with him. And then the other subject is kind of a white paper by Joe Romm, who's a long-time climate writer, journalist, etc., communicator. I've known Joe for 15 plus years. And he's talking about how direct air capture isn't feasible. So we'll go through that. But what I want to do, and let me, let's see, best way to share the screen is, I think this way. Okay, so let's get back to the top. No, that's Joe's thing. Okay, I go to Zoom, I go to share screen, and here we go. So this is what we'll be talking about, at least to start off with. This is a follow-up. So Jim Hansen and Leon and others put together this paper, and we talked about the paper, and you can look at the past live streams of that, or last Climate Chat rooms. And then they did some follow-up, I call them newsletters, white papers or whatever. These are not peer-reviewed. These are things written more for the public rather than for other researchers. And they're sort of explainers about what's happening and trying to focus in on some of the key issues. So, so that's what's is going on here. And so the title of this newsletter just came out a couple of days ago is how we know that global warming is accelerating and that the goal of the Paris Agreement is dead. And by the goal of the Paris Agreement, by what he means there is the Paris Agreement said that everyone will keep warming well below 2 degrees and try to keep it below 1.5 degrees of warming, and that's Celsius. And in the paper, and practically speaking, we're at 1.5 right now. So obviously, but when you take into account the higher warming and higher cooling aspects of the paper, that also essentially puts another nail in the coffin of 1.5 degrees. And as Jim Hansen argues, it also puts a nail in the coffin of 2 degrees as well, even though we haven't reached 2 degrees. Although on that note, Leon Simons posted yesterday that we actually hit 2 degrees global warming across the entire planet on a daily basis for the first time ever, I guess, just the other day. So there's that. And when you start off with a day, then it eventually makes it to be a month average. And then, of course, you get a year average. By the way, even a year average is not enough to say we've crossed 2 degrees. I mean, it could be that you go up for a year and then you go down. And then if you weren't continuing to put greenhouse gases in the atmosphere, you could just go up and go above and below 2 degrees forever. And that would be at 2 degrees, not above. But of course, we are putting greenhouse gases in the atmosphere. Yeah, go ahead.
I mean, this is the thing. We only get certainty when we're really screwed. Right. Until then, there's uncertainty.
That's right. But I'm not even really talking about that. I'm just talking about like the definition of it. The definition of being above 2 degrees is not being above at one time, like because of an El Nino. It's crossing the trend line. So it's sort of the temperature without an El Nino or without a La Nina. Now, according to Hansen, next year, with the El Nino kicking in, so with the extra warming of the El Nino, we should be at 1.6 or 1.7 degrees of warming, which is above 1.5. And his point is that El Nino only adds 0.2 or 0.3. So, if you take that off and you're at 1.7, you're at 1.5 or 1.4. And so he said, you're essentially there, as he put it, for all practical purposes. And of course, if we continue to clean up our pollution, which we are trying to do, and again, this pollution is bad. It kills millions of people a year. So it's a good thing to clean it up. But if we continue to clean it up, then that extra cooling, which is more than what the IPCC says, will continue to kick in and continue to accelerate warming above what the IPCC predicted. So that's a little bit on that. And that's essentially what this paper is about. So it says, and some basic concepts that are really important to know, and we've talked about them before, but they're so important, I think, that they're worth repeating. And that is that there's something called the Earth energy imbalance. And what that is that the Earth absorbs energy from the sun, and the sun heats up the Earth. That makes the Earth warmer, and the Earth, therefore, radiates heat out into space. And if it was a black ball with no atmosphere, there would be a certain balance. And that balance actually would be below freezing. So if there was no atmosphere and the Earth had water on it, for example, it would be a frozen snowball. But because there is an atmosphere and it has some CO2 and other greenhouse gases in it, that the greenhouse gases trap some of the heat that radiates out into space, just like a blanket does when you're camping outside. And so you put a blanket over you to keep yourself warm. You're trapping some of the heat you would have otherwise radiated out to the atmosphere there, and you keep it close to you. And that's the same thing as the greenhouse gases. So those greenhouse gases, did a good job and had a good temperature for human civilization to develop. And then, however, then we have increased the CO2 by 50% so far. So from 280 parts per million to 420 parts per million. And so we've made the blanket thicker, and that's trapping more heat. Now, and in fact, if you throw in the other greenhouse gases like methane and nitrous oxide and all the other gases, and you add them all together, you get a CO2 equivalent factor. And according to Hansen, we've actually doubled the CO2 equivalent factor. So we've increased CO2 by 50%, add up all the other greenhouse gases, you sort of got another 50% of equivalent warming, and we're at a doubling. And there's something called, so that's Earth energy imbalance is simply the difference between the energy coming into the Earth and the energy going out. And if there's more energy coming in than going out, the Earth will warm. It's really that simple. And because we have increased greenhouse gases or made the blanket thicker, we are currently trapping more heat than is going out. And the energy equivalent of that trapped, that extra energy coming in and going out is about 1 million Hiroshima atomic bombs going off every day. And when Jim Hansen gave his TED talk in 2012, the number was about 400,000 Hiroshima atomic bombs. And so that the amount, the Earth energy imbalance has gone up a lot, which is why Hansen says with confidence that our warming rate is going to accelerate because the energy imbalance has gone up. Now, there's something called ECS, or equilibrium climate sensitivity, which is it's kind of something used by researchers. It's a scenario. It's not something, it's not a firm thing like, oh, this is what's going to happen. It says, if we double CO2, which again, we have effectively done that now, then the Earth would be in equilibrium with including only short-term feedbacks, not the long-term feedbacks like, if you melt all of Greenland, then the land would absorb more heat than the reflective ice does, for example. That'd take a long, long time for that to happen. But shorter-term feedbacks, then the warming would be, for doubling CO2, would be 4.8 degrees, is what Hansen says, but the IPCC says it's 3 degrees. And this is a big controversy, and scientists are arguing with each other over this and things like that. Keep in mind that we've essentially doubled already, but we haven't doubled the warming. I mean, we haven't gotten 4.8 degrees of warming. First of all, if we separate, and Hansen said there's 2 reasons for that. One, and this is what he covers in this newsletter. One is, of course, there's aerosols that cool the Earth. So this is man-made pollution that has reflective particles that cool the Earth 2 ways. One is they directly reflect the sun, so they're light colored. They reflect the sun that cools the Earth. But they also form the seeds of clouds, so that water droplets can form around them, and that does 3 things. It creates new clouds. It makes clouds brighter because there's more particles, and more particles mean finer cloud droplets. Finer cloud droplets are brighter clouds. And it also makes the clouds last longer. So those 3 things cause cooling. So that's one reason why, even though we have a doubling of CO2 equivalent forcing, we don't have that much yet in warming. The second thing, which is also a really big reason, is that the oceans take up 90% of the heat of global warming, and the atmosphere only less than 10%. And so what happened is there's a long time between the time we put up greenhouse gases and that we feel the effect. He said it takes 100 years for 60% of the effect to kick in. And so far, most of the greenhouse gases in the atmosphere have been released within the past 50 years. So you basically just wait and it'll get a lot warmer, is one way to say it. Now, there is a counter to that. If we actually stopped emitting, there's a counter to that. Of course, we're not stopping our emissions, but if we stopped our emissions, then the oceans would continue to take up CO2, even though we're not putting out new CO2, and that would lower CO2 levels, which would hopefully bring us down at the same time this latent warming is going up. This warming that we're waiting for is going up. And the 2, it used to be thought that the 2 would cancel each other out, but with Hansen's new, but that they would cancel out if the climate sensitivity was 3 degrees. But if it's 4.8 degrees, then there's going to be extra warming, even if we did bring our emissions to 0. So that's a little bit of that. Let me check in here. Does anyone here that's on Zoom have any questions or comments on what we've mentioned so far? Oh, I see Stacy is here. Let me make you a co-host, Stacy. There we go. So, all right. And so actually, Albert's here, and first of all, Albert's working on a really interesting new book. In fact, Albert, if you want to come on, just tell us a few moments what this book is about. I had a chance to take a peek at it, and it's just like we like to take on controversial subjects here on Climate Chat. In fact, we've covered, we talked about population a long, long time ago. Albert's doing a book on population and what that means for the world. Albert, do you want to mention a few words about that? Are you ready to do that? He may not be ready. He may not even be listening. All right. And Stacy, can you hear me okay? Is everything, am I coming across well?
Yes, loud and clear.
Great. Okay. So, so rather than go into the details of this paper, I'm sorry, not the paper. This is the newsletter. It basically gets into the reasoning behind what I just summarized for you. That those are some of the main findings. That the ocean is taking up a lot of heat. If we look at the amount of radiation, solar radiation absorbed by the Earth, in this graph here, you can see it's kind of going up rather fast, while the amount emitted by the Earth is not going up very fast. Now, as the Earth gets warmer, it will put out more heat. That's what it does, right? And that's how it gets in balance. It warms up until the amount going out is equal to the amount going in. But this also says there's something happening. There's a difference happening between the amount being absorbed and the amount going out. And if aerosols or pollution is going down, that would reflect less sunlight away from the Earth and more sunlight would be absorbed. And that's exactly what we're observing here. And this is all happening since 2015, when the International Maritime Organization passed a rule to say ships that were using this really horrible fuel, really polluting fuel called bunker fuel, had to use lower sulfur fuel. And then the rule kicked in 2020 that it had to be much less, like 80% less. And so you can see that since 2015, the amount of absorbed solar radiation went up dramatically, and then it went up dramatically some more after the more stringent rules kicked in. And a very interesting thing I saw that Hansen addresses in this newsletter is that, well, what about China? Because China has been cleaning up sulfur pollution from its coal plants for quite a while. And it's been dropping its sulfur pollution dramatically. So why didn't it start going up then rather than waiting for the shipping? And he said it might be due to the fact that there's so much other pollution in China that the sulfur pollution wasn't really just the driving factor for example, creating clouds that would reflect the sun away. There was enough other pollution to do that. But over the pristine oceans where nothing else is happening, except for the ship pollution, and all of a sudden you lower the ship pollution, that could have a dramatic impact on reflectivity and on clouds, and therefore on warming of the Earth. So I thought that was interesting. I was kind of wondering that myself, because I always felt that the dramatic decrease in sulfur pollution by China was a major driving factor, but that's how we explained it. Some people think
just
it's
if you look,
yeah,
if you look at the maps of methane emissions, there's a lot of methane coming from China.
Right. Yeah. And US and other places. Yeah, there's other things happening too. That's part of the other greenhouse gases that get us to the doubled warming. Here Hansen is saying that this little up and down line is the sun radiance, and it varies with the 11-year solar cycle, like sunspot cycle. And the point is that in 2015, if you want to argue it was the sun doing it, actually in 2015, the sun was dropping in energy on the Earth, and just now is going up. But during this time that it jumped a lot, it was actually in a low point. So it's not the sun. He also explains it's not the Hungatong volcano. And the bottom line of all of this is that he's very confident in saying that the former trend line since 1970s of a straight line warming of 0.18 degrees per decade is actually now at least 50% higher, and maybe double that. And that's what this yellow band would be. The bottom of the yellow band, I guess, would be 50%, and the other one would be 100% warmer, 0.36 degrees. And that's a big difference in warming. And he said this little pink box up here, that's the predicted temperature next year, between 1.6 and 1.7 degrees. That's even above the yellow band. But remember, it's an El Nino year. So an El Nino year would be above the trend, and a La Nina year would be below. And by the way, that these little dots here on this green line, they're the La Nina years. And notice they're on the line. They're not below the line like they should be if it's a La Nina year. So that suggests that the line is not correct and the actual line is higher. And that's one of the ways that Hansen knows that too. So so we'll see next year. If it's up this high, that means we're not on the green line. We're on the yellow line, somewhere in the yellow area. So there's that. So I want to finish up on that. I mean, there's a lot in here. It's kind of detailed, but it's like a little mini paper, really. But it tries to be written for relatively general audience. I think we summarized the high level points. But I do want to open it up for questions on this particular subject so that we can move on to another subject. So does anyone here in the audience have any questions? Stacy, you have any questions about what we're doing here? We're talking about here?
I'm curious, the methane, is it, it's all the same usual sources, or because they don't do oil, like there isn't oil in China, right?
Well, they're actually, I think they're third in natural gas. So the US is number 1, Russia's number 2, and China's number 3.
Oh, okay. So they
and natural
do,
gas is methane. Yeah.
Right. I think of it as a byproduct out of oil and escaping out of, wells.
It's actually,
also
you get a lot of it where you have
mining.
coal. Coal mining has a lot of methane. Yeah.
Oh,
Yeah.
okay. Well, hey, today I learned. You would think I
Yeah.
would have known that before now. Coal mining has a lot of.
But you asked a good question, by the way. A very important question. It's like, where is this methane coming from? And some of it certainly is coming from oil and gas exploration. There was a big jump. So methane is kind of following this curve where it was going up and then it leveled off. And I'm talking about atmospheric methane now. That it went up and then it leveled off for a decade or so, and it flattened out. Wow, that's great. And then it started going up dramatically again, and it started going up when we figured out how to do fracking. Because with fracking, you're just going at it, and there's millions of these small wells, and no one's really being careful about methane leaks or anything like that. So, and Bob Howarth, who we interviewed a long time ago, was an expert on methane at Cornell. He did a talk that I watched where basically saying that a lot of the new methane was coming from that. However, right now, with the fracking kind of leveling off and the methane still going up, there's other potential sources. So one is cows. Cows give off a lot of methane, but a constant number of cows won't increase methane. So the thing about methane that's different than CO2. CO2 is totally cumulative in the atmosphere. Like you put it up, half the oceans capture half, and oceans, soils, and plants capture half, roughly a little more than half. But half of the methane we release, but the rest stays up there forever, just accumulating, never going away. Methane is different. Methane goes away on its own in 10 to 20 years. So let's say the cows didn't exist, and all of a sudden you had 1 million cows. There we go. We're going to let Albert in again. So you have 1 million cows. So all of a sudden methane would go up because you have all these cows. But if you kept it at 1 million cows, after about 20 years, the amount of methane that was disappearing would equal the amount that is appearing from the cows, and the methane level would just level off. It wouldn't go up anymore. But we are increasing cows, so it's going up a little bit because of that. But what the scary thing is that the new methane may not be coming from oil extraction or gas wells. It may not be coming from cows, but it may be coming from Earth sources due to our warming of the planet. And two of the scary ones would be from the permafrost. So the permafrost is frozen organic matter. Think of it as dead plants and stuff like that. And in areas that got cold, and then the ground froze, and it's like you put those plants in the freezer. So they're still frozen. They didn't deteriorate. But if you melt them because of global warming and you let the ground that was formerly known as permafrost become unfrosted soil, then those plants would deteriorate and break down. And if it's done in air, they'll give off CO2. But if that permafrost melts and makes a pool of water where the plant matter all of a sudden is unfrozen, then microbes will turn the plant matter into methane. So permafrost melting, which is definitely a well-known feedback for climate. In other words, you warm the earth by giving off CO2 from coal and fossil fuels. You warm the earth enough to start melting the permafrost. The permafrost then starts giving off CO2 and methane, which warms the earth more, which gives off more CO2 and methane from permafrost. And permafrost is not a little thing. It's estimated that the permafrost holds twice as much CO2 as the entire atmosphere holds. So even melting, 10% of it is just a huge, huge deal.
And
so
that's if we're lucky and it gets metabolized, to CO2 in terms of
CO2.
what it holds. And if we're not lucky, it's much worse. And I'll add another natural source, a couple of natural sources. One we know about that humans are behind rice paddies. And that's kind of a variable source, but also peatlands. And there's a lot of peatlands in Siberia. So like when there are those huge forest fires in Siberia, a lot of them overlap or are really close to peatlands, and that winds up emitting some methane in the process, even though it's a fire.
There was a paper that just came out, I think in the last week or 10 days, and I don't have the reference. If I can find it, I maybe can stick it in a chat or something, but it looked at this recent spike in methane, and it did isotopic analysis looking at carbon 14, carbon 13, carbon 12, carbon 11. And based on that, it said it's probably this current spike that we're experiencing, which we also experienced in 2020, is tropic in origin and biogenic in origin. So it's not coming from the permafrost in the far north. It's not coming from permafrost or clathrates being uniced. It's coming from the tropics, equatorial regions, and it's probably not rice paddies. It's most likely wetlands and swampy areas. And some of that is the feedback of increased precipitation because the air holds more moisture and because you're getting more extreme events. And so we're getting flooding in low areas. And that's also causing plants to be inundated and die and put out methane to the atmosphere. That and sea level rise in the equatorial region causing coastal flooding, which increases the amount of methane being produced in coastal areas. So that seems to be the source of the current spike based on isotopic analysis.
But also thinking, though, that there's also more cows around the trop in Brazil, and things are cutting down forests to make more food for cows and things like that. I wonder if that's enough to move the needle there, because that would also come up as biogenic. Right?
Yes, it would. Cows, and particularly in Brazil and like that, are very likely to be a source. And rice to some extent, although they said that rice is not likely to be the major one because they looked at rice crop production and how rice crop production hasn't been increasing. That would explain the spike.
Okay. And Albert, I don't know if you heard
just to emphasize, when you have flooding and plants, which were a CO2 sink, right, now die and start decomposing underwater if it's not well oxidized water. So if you think of a lake with wind blowing across it, that creates currents and it mixes and you get decent oxygenation. If instead you have standing water that's not being agitated for extended periods of time, you get anoxic decomposition, and that is a methane source.
Okay. Let's see. One thing just in general, by the way, about climate chat here. One thing, as we move to YouTube streaming, I think that shorter rooms are going to be more well received than 2 and 3 hour rooms. So I'm thinking that we could really, rather than get into the nitty gritty details of things we talk about, although we can certainly maybe have sort of an after room that does that, that we can focus sort of on a number of subjects and cover them at higher levels. I'm also planning on doing new technology here to improve the quality of what it looks like. I haven't had a chance to do that. I'm visiting my dad right now in Toronto, who's not feeling well. He's 92. And so I'm out here visiting him. Didn't have a chance to switch over to the Restream technology I want to start using. And that would also allow us to stream to more platforms, which will also be good. And then we can hopefully, publicize these rooms a little bit more ahead of time, which is hard to do when you're using Zoom, since Zoom streams to a new channel essentially on YouTube when you turn it on, and you can't like send that out ahead of time. So anyway, so that's what I think the high level things we're going to try to do here on Climate Chat as we move to new things. And Albert, I maybe you didn't hear me before. I don't know if you want to talk about your book, since it's quite a while, I think, before it's going to be published, but do you want to say a few words about the upcoming book, which you gave me a chance to take a peek at the other day?
Yeah, it's actually coming out for a pre-order on November 20th on Amazon.
Oh, wow.
It's called Retrop Populationism. And this is part of a series I've been working on for a number of years now. I was asked by a publisher to do a short set on various different environmental issues. And the idea was to come out with an adult version and follow that a year later with a children's version, middle schooler version. And so the first one in that series was about plastic and transforming plastic. And then the children's version was called Taming Plastic, what kids can do about plastic. And then the next one was about ocean and the dark side of the ocean, the blue economy. And then the kids' version was called Making Waves, How to Be an Ocean Activist. And this latest one is about population. It's kind of looking at the debate going on between those who think we are going to need more people. We're going to need to increase fertility because we're losing our social security net because we're not going to be able to pay it forward anymore. And, Elon Musk wants to colonize Mars. He needs a lot more recruits. So there's that side of it. And then there's the other side of it, thinking that, actually we're already past so many planetary boundaries. How can we possibly keep adding more people? You can count up.
Oh, you just froze, Albert. Might be your Starlink. Speaking of Elon Musk. Or maybe he heard what you were saying. Looks like we lost Eli. We'll let him back in. Let's see. I hope, Stacey, are you still hearing me?
Yes, it's so funny because while I quickly clicked Eli on, I glanced over, but I wonder if you're on Starlink and you.
I think Elon heard you talking about Starlink and he cut you off or something.
I am on Starlink. You're right. Is that what happened? I
don't know, but that was very coincidental.
Yeah. Okay. So
that was like the last 30 seconds or so. But.
Right. I don't know where I dropped out. Maybe Elon's a dog fan and I offended him. But so whether China is why did China change its one-child policy, and what's it learned from both sides of that coin now? And Nigeria is going to overtake India, which is overtaking China in population. And
Nigeria?
Yes.
What's it at now?
Yeah, Nigeria is coming. It's up. Yeah.
What's it at now?
I don't know what it's at right now.
But you're talking the rate at which they're going. They're not.
Rate, yes. And demographically, by mid-century, probably sooner, maybe 2040, Nigeria will pass China and India in population. And so,
Oh my gosh. I can't really?
So what are we going to do? Will we learn to live forever soon? All this telomere research about how to live longer and life extension. What should we do? What should we worry about? Food and water supplies? What about mass migrations threatening to destabilize whole countries and the climate migration that's coming and so forth? Are we going to somehow solve that with artificial intelligence? So I look at all of these different kind of converging issues, all of which come together around population. And it's kind of a taboo in many ways. A lot of environmental groups don't want to talk about it. There's a whole religious aspect there that you touch a lot of third rails if you start to go in there. But I do not fear to tread. And so this book is kind of breaking all of that down and asking as many questions as I have answers to, but giving you room to think.
Okay, very good. Well, I didn't realize it's coming out that quickly. So everyone keep an eye out for that. I'm sure when it actually comes out, Albert, we'll talk about it more here in the room. Maybe we'll actually do a room on it, because all the subject, it's all related to climate, and you know, the climate is just one of the big planetary problems that we face. There are others, and just fixing climate alone is not going to solve the others, and going to still get us in a lot of trouble, including biodiversity loss and the population overconsumption and all kinds of things. And you know, we're focused on climate because if you don't fix that, well, the other ones won't matter too much. But we actually have to work on all of them. So, but speaking of that, this
brings out a point. What Hansen is doing in this newsletter that we just discussed is looking at the current trends and saying, this is where we're going with the current trends. And the IPCC has only looked a little bit at carbon dioxide removal and isn't looking at anything else. And the else here really is sunlight reflection methods. Right.
That's right. Well, that's what
the same
calls. Yeah. Mm-hmm.
The same can be said for some of these other projections on planetary boundaries. Right. So if you only limit to what exists and what is well known and current trends, these projections would be, spot on most likely. But that doesn't mean that they are our destiny, because there are other things that we can do that have been taken off the table by the design of the discourse.
Right. Well, in Nigeria, for example, if they get better healthcare and better education for women, then their populations will slow dramatically, just like it has in all the other places where that's happened. So there's no reason why Nigeria, and also if they just realize it's not a good world for them, because there's a lot of problems that obviously occur when you get a population like that and the size of Nigeria. So anyway, let's see. But speaking of these other problems, the New York Times has a story today in the Sunday New York Times about how environmental groups are finding it hard to raise money for non-climate actions. So a lot of these groups that focused on toxic chemicals or nuclear waste, things like that, they're having trouble raising money for it for a number of reasons, and one of them being that young people who are controlling more and more of these philanthropies as they get older and their parents die and they take over or whatever, they want to address climate change. I actually personally think it's a good thing. I was at a very, very early meeting with the Sierra Club, and this is before they were doing climate, and they brought in some outside people to talk to them. And as I told them then, which was really 20 years ago or something, a long time ago, I told them, there are not going to be any more owls in the woods if we don't address climate change. So we better get on it. And to their credit, it took them a little while, but they did actually get on board and turn this big ship around. And so they're trying to address climate change as well. They couldn't argue with their methods, but whatever, but still it's good. So that's, if you check out the New York Times today, if you want to see that story about how nonprofits, environmental nonprofits, are having trouble raising money for things that aren't climate related. Let's move on to it. So I'm going to keep this one going, maybe do a shorter room, but cover controversial subjects. By the way, one reason we're covering the Hansen paper, it's not just like this new paper. It's a fundamental paper saying basically all the research of the last 20 years is off. I mean, all this IPCC stuff that the whole world relies on is wrong. Now, to be fair, other climate scientists, well-respected climate, let's leave Michael Mann out of it, who seems to be a little strange about this, but respected climate scientists that are still working in climate science are saying that, no, look, Hansen, well, they're not saying that he's wrong. They're not going to go out and say that, but they're saying, look, this is one paper, and there are other papers using similar methods and similar data that come to very different conclusions. So it could be that Hansen is wrong, and that's a possibility, certainly. However, Leon Simons, who's been on this show multiple times, he's saying, look, guys, look at the data. I mean, it explains what we're seeing. And the other climate scientists can't explain what we're seeing. This very rapid warming in just the last year. Now, they're saying it might just be an anomaly, just a spike, El Nino after 3 years of La Nina, and all of a sudden there's a big spike. And sure, that's what we're seeing, and it's going to come down again. Well, if that happens, then probably Hansen is wrong. But if we get 1.6, 1.7 next year, and again, we're at 2 right this moment, which is pretty scary.
I want to make a really basic point here. In science, you at the very least you acknowledge the hypothesis that best explains the data, right? And they're doing their best to try and reject that in favor of one that is less troublesome.
No, I don't know. Maybe some of them. That might be Michael Mann, by the way. But I think these other folks are like Zeke and whatever. They're saying, look at the papers, look at the data. They explain it this way, and and it says it's a lot less than what Hansen said. We're talking about the climate sensitivity now. That's the debate. Is it 3? And keep in mind that even the IPCC says it could be anything from 2 to 4.5, but with a central value of 3. But even Hansen's 4 point is above the 4.5, right? And there's other people that say it could be as high as 5, and there's lots of research out there. But they use 3 in their models, and that's what they tell the world about what the warming is going to be. And if Hansen is right, which again, I wouldn't bet against Jim Hansen. I've known a long time. He's been right. And you got to remember, he was saying these things in 1980s when no one else was saying anything about this stuff, really, in terms of the details. And he published predictions that I just saw today. Some climate denier trying to say he was way off, but they misinterpret it, because what he did in the 1980s is that we don't know what man's emissions are going to actually be, and that's going to determine what the temperature is. But we can take like a high scenario where people emit as much as they possibly can, one where they cut back on emissions as much as they can, and another one where they kind of follow what we're doing now. And the scenario B turned out to be pretty accurate. And this was, again, with very limited modeling capability back in the 1980s for this kind of stuff. And he got it about right. And I would also argue that Svante Arrhenius in 1896, who published the first paper on global warming, who did the same calculation that Jim is doing here, by the way, came up with, I think it was in the 4C range for climate sensitivity in 1896, no computers, all by hand calculations. And he got it roughly about right. Of course, the thing was, back then he thought we wouldn't double CO2 for another 3,000 years, but but we figured out that's what exponentials do for you, by the way. If you keep doubling something every year, you grow very, very rapidly. Anyway, what else on this? I don't know. It's a interesting subject, so we're going to continue to talk about it. I'd like to get Leon in here and talk about the controversy more, about what other scientists are saying and how he responds to them. He's getting like personal insults thrown at him. Oh, you're not even a climate scientist and all this kind of stuff. And he's probably doing the leading work today on the aerosol reduction and therefore temperature increases that we're seeing. And that's why Jim Hansen's partnering with him as a co-author. So anyway, yeah, Stacy, you have something?
Just
No,
a quick
yeah, just
point.
that the level of gatekeeping is it's troublesome. If
Did you post it? Did you post it publicly?
what?
Because you can only for the Zoom you can only get in by going to the Clubhouse room.
I didn't. What do you?
But what
Oh,
gatekeeping
no.
are you talking about?
Oh, gatekeeping. No, the Michael Mann thing. He's not
You're
a
not a
climate
climate
scientist.
scientist.
Oh, I
You
thought
know,
you were talking
it's-
about the gatekeeping for this room. I see.
Oh,
No, okay, go ahead.
No, the gatekeeping of who's allowed to produce work on climate science. It's if it were not credible, if it were not well researched, if it were just pontification or whatever, fine. You can hurl whatever you want, but when you actually have the data backing it up, it makes the real scientist look rather foolish,
Well, to be fair to the real scientists, they have data too, and they have analysis too. But there's so much data and so much analysis you can do. So Hansen, I think I always like him because he looks at the big picture and he pulls together all these different things. Paleo climate. His basic argument is that the IPCC relies too much on modeling and not enough on looking at the data from the past. And so he looks at the data from the past, but other people do too. And they come up with different results. So to be fair, we're not talking about Michael Mann, where he's not even arguing the data. He's just saying,
that's what I'm saying. That's what I'm saying. It's
So that's Michael Mann. But Michael Mann is also, and I still can't believe he said this, because he said in his rebuttal that came out like right away, so it looked like he didn't do much research, to really look at it. But he said in one of the beginning things, the rule of thumb, he said, is that if we get to net zero by 2050, we can keep under 1.5 degrees of warming. Now that is crazy. We're at 1.5 degrees of warming right now. And you could argue, okay, maybe it's not quite yet. It's going to be, late 2020s, early 2030s, but there isn't any scenario, including net, even if we could get to net zero, even if we could, we're not going to do it. But if we could, by 2050, we're still way over. We're over 2 degrees then too.
Yeah,
I mean, I don't understand. I can't even understand how we can even say that.
Yeah.
Not just that. I mean, that is expressing a degree of certitude about amplifying feedbacks that is simply not empirically validated. We do not have the knowledge and measurements and data to be able to bound feedbacks as confidently as he's saying. But I did want to go back to the whole gatekeeping thing. He could raise that concern if it were a single author paper by a non-climate scientist that was receiving huge attention. It would be something that's valid to say, but still not a strong argument. But the notion here that's being purveyed is that this non-climate scientist has somehow foisted his crackpot ideas on all of these climate scientist co-authors, which is preposterous.
Yeah, and that's the thing. There's not too many rebel scientists that could get away with doing what we're doing than Jim Hansen, is the most cited climate author in history. And and people, and the other scientists also didn't like Jim for not only because he's kind of like pushing the science, but also because he got arrested for protesting the coal plants, oil pipelines, and things like that. He got arrested in front of the White House. I forget. He told me once how many times he was arrested. It was like 80 times or some crazy number.
All
I
right.
didn't realize.
Who was Hansen was arrested?
Hansen. And so scientists, now it's changing now, very interesting, changing now. But at the time, not that long ago, felt that a scientist who takes a political stand is sort of tainting his scientific credentials, because you're supposed to be dispassionate and only look at the data and not have a political agenda, right? But of course, Hansen, who is like, he's a conservative from Iowa, just so you know.
Right,
This guy is not a liberal anything, you know.
But we'll call it stole clutching, you know, or lab coat clutching or something.
Lab coat.
Yeah.
But he only did this because he understood the science. He didn't come up with the science because he's wanted to protest the government. He looked at the science and said, "Oh my God, these are my grandchildren are going to be screwed by this. I better really make some noise here. What if I just sat quietly like everybody else is doing? Then how could I, look back on my life and stuff like that?" And he wrote this in his book, by the way, so you can read about it. Storms of My Grandchildren. I'm my dad's place, so I don't have a copy here to show. But Storms of My Grandchildren. It's a pretty detailed book, but an interesting book for those who want to see. By the way, more of the history of his time, and one of the most amazing stories, and I'll just go for Jim Hansen, is he was at NASA. And he gave this talk on how climate change is going to be really bad. And this was like the Bush administration. So they told him and through others that he can't talk about it. Like, you can't talk about that. But then he looked at the mission statement of NASA, which was, and I'm going to paraphrase here, but it was like to explore the universe and to understand our place here on Earth.
Planet, yeah.
Our home planet, right? And so he said, "Oh, so the mission statement is to understand the Earth and protect the Earth. So got to do it. That's the mission statement of NASA. I have to do it." So he argued that, and then he ended up getting a senator to protect him against being fired, basically. So he did it. And then you know what the Bush administration did? They changed the mission statement of NASA and removed the part about the Earth. They did.
Oh my God. And has it ever been changed back, or is
I don't know if it's been changed back, actually.
It should be, because now we have Space Force.
Someone go look up mission statement of NASA. I can't do it right now. See if it has the Earth back in there or not.
I will look.
So okay, all right. So we covered that pretty well. So it's an interest. So not only is the science really interesting, this new paper, because it's a breakthrough paper that it's saying things that science. This is not a little incremental thing that we learned a little bit more about this one little tiny area. This is the whole, the whole thing, the whole enchilada, and saying there's both more warming from greenhouse gases and more cooling from aerosols, which gives the same temperature as NASA comes up with less warming and less cooling. They both come out to be the same. But as we get rid of the aerosol pollution, that means we're going to have far more warming than everyone thought. And that's what and it's not like some theoretical thing sometime in the future. It's what we are seeing right now. And it's why this year will be the warmest year ever by far, at like 1.5 degrees of warming. And next year will be even warmer. So this is not theoretical. This is real. This is your life. This is your family's life and your children's lives and everything. So it's a very important paper, but that's scientifically. But it's also interesting about the feedback that's coming and the pushback from scientists and things like that. And so I actually want to cover like both of those. And I think to cover some of that pushback, we'll wait for Leon to join us. And by the way, if anyone sees him in the audience here, I don't think I see everybody. Give me a holler right away. If he comes to the waiting room, for example. He said he might try. But let's switch. So Albert mentioned that perhaps the room is covering the Hansen thing just a little bit too much, because that's what we've done for the last 3 weeks here. And he suggested another thing, and this is an area that I push back on Twitter all the time. So I thought it would be a good one too. And this is Joe Rome. And Joe, what was Joe's actual thing back when I first met him? He had one of the first climate blogs, really, and this is a long time ago, really long time ago. So So, but Joe's a climate community, like kind of like me, but more well known, has been around a long time, and talks about like how to communicate about climate and all these kinds of things.
Hey,
And
Dan,
so
can we ask questions as you go along?
Oh yeah, about this one or about the
about
past
this
one
one
or what?
About this
Yeah,
one.
yeah. Oh, yeah.
Okay, so just
Yeah.
a question: has anybody, and I'm sure the answer, I hope the answer is yes, but has anybody done a business analysis of direct air carbon capture versus doing it via growing trees and stuff like that?
Oh, sure. Well, that's what this is about too, by the way. And problem is, growing trees doesn't really solve the problem, and he talks about that in this paper. You can
Well,
grow
you will have to dump the trunks in some deep well or something. I don't know.
Well, also it would be an environmental disaster to grow that many trees, if you think about it. Trees use water.
But comparing it with direct air carbon from a business perspective.
Yeah. Well, first of all, we'll talk about that. But forget the business case just for a moment, because he's trying to say it just doesn't work. It doesn't scale. It makes no sense. But I want to point out that the important thing about this is the question he is asking is not one that anyone is asking. I'm sorry, the question he is answering is not a question that anyone's asking. He's saying, does it make sense to have like a coal-powered power plant making electricity, and then to get rid of those emissions by using direct air capture? The answer to that question is no. It's a stupid thing to do. So, period. And his whole paper is like, why it makes no sense and everything. Of course, it makes no sense. Let's look at it very simply. The coal power plant today costs more than building clean renewable energy, and that's not taking into account the climate damage of the CO2 given off by the coal and all the other horrible things that kills people, right? The pollution is horrible, right? So, but that's today, renewables are cheaper. Now, if you said, I'm going to forget direct air capture, I'm going to just put carbon capture, CCS, directly on the coal plant, which is much cheaper than to take the CO2 out of the smokestack. When it's concentrated, it's 10 to 20% of the stuff coming out of the smokestack, where in the air is 0.04% CO2. So that's cheaper, but that even makes no sense whatsoever, because now all you did is take this more expensive coal plant and made it even more expensive, and it still won't be as clean as the renewable energy. So the answer is a resounding, of course not, to should you use DAC, or direct air capture out of the atmosphere capture, to offset a coal plant? Of course not. Or anything else for that matter. Anything, we need to bring our emissions down to zero, as close to zero as we can. But the problem is, and here's the problem he doesn't address here at all, even when we do that, there will be too much CO2 in the atmosphere. So if there's too much CO2 in the atmosphere, then what do? Well, going to renewable energy doesn't reduce CO2 in the atmosphere. I mean, you can argue that it does by, as I mentioned earlier, once we get to zero emissions, the oceans will continue to take up CO2 at the same rate it did before we cut our emissions, because it's based on the total. The ocean doesn't know how much emissions we did this year. It only knows what the total is in the atmosphere and how much is in the oceans. And it's the difference between the two, that the over pressure of CO2 in the atmosphere versus the ocean, that causes the oceans to absorb CO2. So once we stop emissions, let's say we just turned off emissions right this moment, the oceans wouldn't know anything happened, because the current emissions are a tiny, tiny percent of the total emissions, extra CO2 that we already put up there. We put up 2.4 billion tons into the atmosphere, about 1.1 or so, 1.2 is remaining in the atmosphere. And every year we put up 40 billion. So we're putting up a tiny fraction, a couple of percent, 1.5%, 2% of the total every year. So if we cut it to zero, okay, it'd be a couple percent less, but still the big overpressure would still be there, and the oceans would continue to take up CO2. So CO2 levels would drop.
Actually,
yeah.
The ocean atmosphere equilibrium is approximately 1 year. So when there are new emissions, yes, it'd be, a third, 40% roughly or so, winds up being taken up by the ocean. You stop emissions, right? That essentially stops. It would continue if, for example, net primary production in the ocean were increasing. In sad actual fact, however, it is decreasing, which is an ecological catastrophe all by itself.
Well, that would also mean it would pull up more CO2. No,
it's soil.
You're saying that's part of how it absorbs CO2.
Yeah, it's really soil and plant.
I don't think you're right about this. I don't think it would take a year to stabilize. I think it'd take much more longer than that, because there is ocean mixing. By the way, I also learned something this week from Chuck Green. Chuck Green was a professor of oceanography at Cornell, and he and I did a paper together 10 years ago, which I talked about previously. Did very well. It basically where we are today, showing that we need carbon capture and solar radiation management. This was I think it was 2010 or something like that, a long time ago. Anyway, he wrote to me and told me that because of ocean mixing, a lot of the CO2. So the general story is we put out 2.4 billion tons, and about 1.1, 1.2 remains. But if we took the 1.1 out of the atmosphere, then the oceans would give back, because the overpressure would be the opposite direction now, and it would give back the CO2 that it absorbed before. So you actually have to restore all 2.4 billion tons in order to be safe. And Chuck Green was saying, no, because so much of that CO2 is actually cycled down deep into the ocean and won't come out for a long time. It won't outgas into the atmosphere. And so you don't need to take I think you still have to take more than 1.1. And we didn't really get into like how much do you have to take. But basically he was saying you don't have to take all 2.4.
Okay, so
I hope he's right, by the way. That'd be great.
If you're only looking at the atmosphere, yes, that's true. But this is the thing. The ocean is trapped in an abusive relationship with humans. If you just stop there and rely on ocean mixing, you're leaving ocean acidification unaddressed, which is another one of these ecological catastrophes all by itself. And if we want to restore climate,
although I think the deep ocean might be different.
Ecology.
Yeah, but if it's stored in the deep ocean, it may not be the same as the CO2 near the surface. That's kind of his point. Is that if it's near the surface, yes, it's going to outgas and equalize, but otherwise it won't be up there.
It's the photic layer and the upper parts of the water column where there's a lot of calcifying organisms that are threatened by ocean acidification, and that isn't going away by itself.
And he talked about it's also the overturning circulations that get it down deep. And I said, well, I wouldn't trust the AMOC to continue to do that. He goes, yeah, you're right, but that also means it's not going to bring it up either. It's not going to bring the CO2 back up to the surface. So it should stay for a long time. I hope he's right. And this is where you get into these levels. And climate science is really interesting because, it's like if you switch from coal to natural gas, and natural gas gives off half the CO2 that coal does per unit of electricity generated. That sounds like a good thing, but it turns out that doing that increases global temperatures for like 100 years, because natural gas, in the tiny bit of leakage of natural gas has such a strong warming component. Plus, it doesn't have the cooling aerosols that coal has. And so anyways, so things are not like what they are on the surface. You have to look at multiple layers to see, is that going to have a positive effect or a negative effect? And you have to keep looking at more and more layers. And very often it's unintended consequences and secondary effects that really get you, as we're about to find out, by the way, because, we know 2 degrees of warming will be really bad because of heat waves and droughts and floods. And, we can probably make a list of really bad things that happen at certain tipping points. But there's a whole bunch of things that we don't know yet that are going to happen too at 2 degrees. We forgot, the thing with the bees, for example, we get rid of the bees through a whole bunch of different, there's toxicity and whatever and changing habitats. But then, we can't grow food without the bees or a lot of different kinds of food.
So this is, we can hope for the best, right? And that's the risk that you run, talking about the worst case scenarios, but hoping for the best is not a plan. And
Right.
For a real plan, we have to prepare for the worst.
Well, I think one of the big problems, one of the big problems people have is they have something called optimism bias. And, and so you say, well, it could be this or it could be that. I'm going to think it's going to be the better thing. I'm going to hope with climate change, that's certainly not a good approach, by the way. We should, expect the worst and hope for the best.
Yeah, there's another
plan for the worst.
Optimism bias. It's magical thinking, right? And we're not going to think our way out of this.
It's not exactly magical thinking. I mean, it could be. There's a chance it will be okay, and there's a chance it won't be okay. And anybody who plays Russian roulette has optimism bias. The chances are you'll be okay.
but my
anyone who gambles has optimism bias, by the way, if you ever go to a casino.
My point is that we should just plan on dealing with 2.5 to 3 teratons depending on when emissions
I see what you mean.
Finally stop and when we scale up carbon dioxide removal, and that isn't even preparing for the worst, actually, because the worst is when there are natural feedbacks that start releasing methane, for example, and we have other
sure
to deal with on top of everything. So right. Stepping, one more big step backwards is, whether or not, Warren and you regime in uncharted territory, as Hansen and Leon Simons have been saying, and I've been saying, and I think you've been saying, Dan, whether or not we actually are, we should treat it that way, because even if we're wrong, we will at least be ready for when we do get that point, because we are coasting in that direction, right? Whereas if we don't take it seriously this time around, we're all the more likely to be severely screwed in the unfortunate event that's.
Yeah. By the way, I think, hey, let's take care of the first trillion tons, and then we'll think about what we have to do next. I mean, the first trillion tons is a big objective. I don't know. There's a lot of. I'm going to tell you this joke from Saturday Night Live from the 70s that always, when I think about these things, when they say, "Well, it's not 2.4. It's not. That's crazy. It's too much." But so the story was, President Carter. To show you how long ago this was. President Carter was visiting the 3 Mile Island nuclear plant, and something happens. There's a release of radiation or something, and so then they're holding a press conference later, and a reporter stands up and says, "Is it true? Is it true that the president is 100 feet tall?" And the press secretary says, "No, of course not. That's ridiculous. There's no truth to that whatsoever. Crazy." And then the next reporter says, "Is it true that he's 90 feet tall?" No comment. So that's a little bit when I think about some of these things about, we don't have to do 2.4. A billion will be, a trillion will be enough. Okay. All right. Okay, fine. Let's focus on the trillion and not worry about some of these other things. Somehow that joke comes up a lot in climate discussions where people are emphasizing that thing isn't quite as bad as someone is saying, yet it's still pretty much bad anyway. So with that joke, maybe let's open it up for questions, and then we'll call it a day here. Anyone here in the Zoom room have a question? You can raise your hand by going down to reactions. I'm going to hit stop sharing here so I can see more people. You go down to reactions, and then you can say raise hand if you want to do that. And if not, we did an hour and 10 minutes, which I think is probably a good thing to shoot for. We covered a lot, actually. And I think the other thing, when we do it shorter rooms, we cover subjects at a higher level. It might actually be more interesting to a broader group of people, where they kind of hear the basic issue and not delve into the nitty gritty as much. But I don't know. I enjoy doing both, so we'll see how that goes. So with that, I want to thank everyone for joining us. I want to thank everyone on we have Eric with a question there. So Eric, go ahead. You should be able to unmute now, since I asked you to unmute. There we go.
Hey, can I, does that sound good?
Yeah.
Okay, question. Do you think it makes sense to start, or if people are already starting to do more organizing of climate experts to counter the IPCC line that, or the IPCC leadership's line around only reducing greenhouse gas emissions and not treating the other two things so seriously?
That's actually not good. All of the IPCC models that keep us under 2 degrees, all of them at this point, I believe this is a true statement, have carbon capture. They gave up on emissions reduction alone long ago. Now, the problem is that the fossil fuel industry and governments are saying, oh, we don't have to reduce our emissions so much. Look, there's all these scenarios where we stay under 2 degrees. But of course, they all have these crazy amounts of carbon capture. So I look at it differently. I don't see carbon capture as an excuse for business as usual. We have to reduce our emissions as fast as we possibly can. I see carbon capture as a way to reduce CO2 levels far below what the IPCC is trying to do. So the IPCC plan, call it a plan, it's to get to net zero by 2050. And the way we get there is by reducing our emissions quickly, plus doing carbon capture. They call it a BECS. And Joe Rome talks about BECS being ridiculous. I always felt BECS was just a placeholder name. It's bioenergy with carbon capture and sequestration. You burn trees and plants for electricity, and then use carbon capture to capture the CO2 that would have left the plant, put it underground, and then you do it again and again and again. So as the plants grow, they take CO2 from the atmosphere. And when you burn them and capture their CO2, you get rid of that CO2 from the atmosphere. Yes, that technically works, but you're talking about, as he points out, you need to grow an area the size of India or something to have enough biomass for this to make a big difference. Instead, you don't need to use trees and plants. You can do it directly using mechanical means. You can do it by fertilizing the oceans. You can do it by weathering rock. There's lots of different ways. And by the way, the X Prize, you can look up X Prize carbon removal, and you'll see there's a whole bunch of companies competing to win a $50 million prize for the best way to remove CO2 from the air. And there's all different ways being proposed. So, so to answer your question, the IPCC assumes we're going to do carbon capture at a grand scale, and people are complaining, I think rightfully so, that they're using it more as an excuse for continuing business as usual, which certainly should not be that. So I actually think we have to do far more carbon capture than the IPCC says, but not using it as an excuse for continuing what we're doing, but as a way to get back to a safe level of CO2 in the atmosphere.
Maybe I just didn't express the question very well. Let me try again.
Okay.
I don't see a lot of organizing around getting people who have the right kinds of credentials to back up what you're saying, that sun reflection methods plus carbon capture are completely essential. We ought to be, drastically increasing research budgets and being ready to, get the kind of social agreement to actually move forward once, the research gets to certain levels. Does it
Yeah.
does it make sense?
That's true.
To have
Yeah, okay. Mhm.
to have like letters to the editor, that are signed by the most impressive people who agree with you and Eli and Doug about this kind of thing.
Well, forget that. I mean, first of all, the IPCC, they don't propose sunlight reflection methods, right? They don't do that. That's a very controversial subject. But put that aside. They are thousands of respected scientists from around the world, and they write they write a report every 5 years, and they update it all the time. And they say that we have to dramatically and urgently reduce our emissions right away. So, and yeah, Hansen goes even farther, but let's take it as far as the IPCC goes. Governments aren't doing that. So it's not a question of not having enough scientists signing something. All the scientists in the world sign it, and the major climate scientists. And again, they're being conservative, right? They're being it's worse than they say. But governments aren't doing anything anyway. So like, I don't know how having a few more signatures and saying we have to even do more than we were saying before will work.
Well, but
we have a basic problem. I mean, there's certainly a basic problem. The world is not acting the way it needs to. Go ahead,
and the IPCC is unfortunately, Leon Simons had a tweet where he showed how India, and it was scientists from India, but they're acting under direction of their government, struck reference to aerosol effects on climate from the scientific report. It's supposed, it's supposed to be just the scientists, not the politics. But one country decided that no, aerosols are not important. We don't want to talk about them.
Yeah, well, I think there's a lot of can be said about how the IPC mechanism, the whole way it's set up. I mean, it's set up that for the policymaker section, you have to have universal agreement. And surprise, surprise, Saudi Arabia doesn't agree with cutting fossil fuels and things like that. So the whole document, you could say, the whole process is not really, correct, right? However, even with all of that, and with what it does say, which, okay, you can say is too conservative, but even that, we are not doing even close to enough as a world. By the way, the U.S. is reducing. It says it's reducing its emissions, mostly because we're switching from coal to natural gas, but in other countries. But we're not doing even what the conservative IPCC says we should be doing. So I don't know how. Again, so you were asking the grand question. I think put it another way: how do we get the world to act? So far, from what I can tell, the only thing that gets the world to act is climate damage, and knowing that it's climate related, and that's only the last 5 years. Before that, I mean, I've been giving these talks for 20 years, and Hansen longer me. Lots of people giving talks, explaining to policymakers what the impacts are going to be to the public and everything. We've known all this stuff actually since the 1950s, right? And yet, nothing. In fact, since Hansen's talk in 1988 in front of Congress saying we had to cut our emissions grew by 60% since that time. So it is the grand question. So I think there's two things. One, as things get worse, and they will get worse, more and more the public will speak up, and there will be some tipping point there where it will become a public issue. People will protest in the streets and will vote for people only that do this stuff. And that will cause a big change. And also, hopefully, we'll be smarter. We'll get smarter. As we talk often about in climate change, we talk to David Fenton and George Marshall and others about what are better ways to reach out to the public.
Well, what do you
So-
think about coming over this week, Dan, and we can light something on fire at APEC when all the fancy people are here. I don't know.
Yeah, actually, I'm in Toronto here now for my
Oh,
my
right,
dad's
right.
not well, so I'm visiting him. Yeah,
okay,
but
well, if you have an
you take
envoy,
care. But watch it, Stacy. You already had some confrontations with the police already. You might want to be a little careful.
what's I mean, hey,
Don't stand in the
that's not on
street.
record.
Don't stand
Yeah.
in the street. Do it on the sidewalk.
Right? Oh God, no, it's got to be in the street. That's exactly where it all goes. I did want to just loop back around since we were talking about NASA, and so it seems as I couldn't find what it was under the orange clown, but in reading a summary of all the things that he slashed, and and then it's you can assume that he had changed the mission statement as well. It is now at one, I don't know if this is, it says NASA today at its 20 centers and facilities across the country and the only national laboratory in space, NASA studies Earth, including its climate, our sun, and our solar system and beyond. We conduct research, testing, and development to advance aeronautics, including electric propulsion and supersonic flight. We develop and fund space technologies that will enable future exploration and benefit life on Earth. So it seems like that's
here's NASA's mission under Obama.
That was
at
under
least.
Obama. That
Oh.
was, if you look at the,
But it should be there should be a one sentence one, right? That was a very long one. Drive advances in science, technology, aeronautics, and space exploration to enhance knowledge, education, innovation, economic vitality, and stewardship of Earth. So they obviously did go back and change it from what the Bush administration did.
The equivalent now would be NASA explores the unknown in air and space, innovates for the benefit of humanity, and inspires the world through discovery, which doesn't
There we go.
sound as, I guess that's, there we go. That's it.
There we go. Exploring the secrets of the universe for the benefit of all. NASA explores the unknown in air and space, innovates for the benefit of humanity, and inspires the world through discovery. There you go. But when they struck it because of Hansen, I thought that was an amazing response. So with all of that, everyone, thanks so much for coming to Climate Chat. This will be available on YouTube stream, and we're going to figure out how to make it look a little fancier and control the crowds in a different way, and be a little more guest focused kind of program. But thanks everyone for contributing, and especially Albert, thanks for also making the suggestion. I tell people you can write to me at climatechatclub@gmail.com with suggestions for guests and topics. And Albert did that, and we added a topic because of that. So please feel free to do that. And with that, thanks for coming, and we'll see you next time. Bye-bye, everyone.